A standing wave is formed in a pipe open at one end and closed at the other. The length of the pipe is L and the speed of the sound in the pipe is V. N is a positive integer. What expression is correct about the frequencies of the harmonics in the pipe? In the IB Physics data booklet under topic C.2, the wave equation is given. This equation, we will make F the frequency as the subject, where frequency is equal to V, the wave speed, divided by lambda, the wavelength. In the description below, I have given the links to my previous videos on harmonics. Now let's set up the equation for the fundamental wave, or the first harmonic. In this case, we know that we have a closed end on this side and an open end on this side. Therefore, we can only have a node at the closed end. We cannot have a node at the open end. So therefore, the fundamental wave that we can set up in this tube will look like this. So what you are required to remember here is that in harmonics, or in standing wave, one loop is equivalent to lambda over 2. So we have half of a loop, that means this is equivalent to lambda over 4. Now the equation for this wave will be L equal to lambda over 4. If I make lambda as a subject, so we have lambda equal to 4L. Next, we will substitute this lambda into the equation above. So we'll have frequency is equal to V over 4L. Next, we are going to take a look at the next possible standing wave that can form in this pipe. So we already have an existing node there. So what we're going to do next is that we are going to add another node. Therefore, we're going to have a wave which looks like this. The basic wave was lambda over 4. We will be setting up the rest of the wave equation for the wave in the pipe in terms of lambda over 4. So therefore, I'm going to divide this into half. So we have lambda over 4, lambda over 4, and lambda over 4. And we know that the length of the pipe doesn't change, it's still L. So if I rewrite this in terms of L, so we have L is equivalent to 3. We have 1, 2, and a 3. So we have 3 lambda over 4. If I make lambda as a subject, so we're going to have 4 times by L divided by 3. Now back to the previous equation where we had V equal to F lambda, and we had F is equal to V over lambda. If we substitute into this equation, so we're going to have frequency is equal to V over 4L over 3. If we rearrange this equation, we will get V over 4L. That's the frequency. Compare both of these equations, we can see that we have a 3 here and we have a 1 there. We can already see a pattern here where we have 1, next we have 3, and it looks like it is an odd number pattern here. So we can already guess that the next frequency can be F equal to 5V4L. So let's just double check. The next possible harmonic is that we're just going to add an extra note compared to before. We already have a note before here, so now we're just going to add a note somewhere here. So if we draw our wave, the standing wave in the pipe looks like this. Again, because our fundamental wave was lambda over 4, we're going to set up an equation here based on lambda over 4. So I'm going to divide each of this loop into half. So we have lambda over 4, lambda over 4, lambda over 4, another lambda over 4, and lambda over 4. In total, we have 1, 2, 3, 4, and a 5 lambda over 4 there. So now we can say that L is equal to 5 lambda over 4. If I make lambda as a subject, we have 4L over 5. Now, if I substitute that into the original equation where we have f is equal to v over lambda, so we have f is equal to v over 4L over 5. So f is equivalent to 5v over 4L. Now we can clearly see that we have 5 there. Now let's list down the 3 frequencies. Now in these 3 equations, we can clearly see that we have constants where we have v over 4L is a constant. From the choice of the answers, we do have v over 4L for B and v over 4L for D. Now let's focus on the odd numbers in the increasing pattern. The general expression for odd numbers is 2n minus 1. So n equal to 1, 2n minus 1 will become 1. If I substitute n equal to 2, the expression will give us 3, and so on, so on. So the correct answer for this question is B.